Welcome, everyone. Woo! The last video you saw was the promo of, not the promo, the after movie of 2017 ING meetup. That's actually where it all started with our conferences. You see that our camera work got slightly better over the years. That was me walking around with a GoPro back then. I'm just very excited to welcome you all tonight. You won't be hearing a lot from me. I will be handing it over to our greatest MC, Cappy, for this evening, who will be introducing all of the amazing speakers that we have tonight. I just wanted to say hi and that I'm very happy that we're back post-COVID. This is our first back in-person meetup again. It has taken a very long time, so please give yourselves an applause for being here. Our adventure, why we're still here, why we're still doing this, actually started at ING, so that's why we also thought it would be very nice and symbolic to return to ING with the first chance that we had post-COVID. We did a meetup at ING in June 2017. That was for 200 to 300, I think, developers, and that's when we thought maybe we should do a little bit more. So thank you, ING, for making us realize that, because by now we organize JavaScript conferences throughout Amsterdam, the Netherlands, and beyond, actually. I won't bore you with the rest of the details or with the history. I'm just happy that you're all here. I hope that you enjoy all the talks, and please, a big applause for our MC for today, Cappy.
Good evening, good evening. Thank you so much, Jos. Good evening, Amsterdam. It's such a pleasure to be your MC for this evening. It's so nice to see people in real life, don't you think? Wouldn't you just want to reach out and just touch your neighbor? Oh, I'm just kidding. Just kidding. Don't do it. Don't do it. It's all being filmed. But hi to everyone here. Thank you so much for being here. And hi to everyone on the stream. So great for you guys to join us using the wonders of technology as we are appreciating at this very moment. And yeah, I'm Cappy. My full name is Capiche. Whenever I'm in trouble, you can use my full name. That's when I know it's probably my mom on the phone. But hey, I'm here. I'm working at Passionate People as a front-end consultant. And yeah, that's all you need to know about me, because tonight is not about me. It's about these four guys that are going to grace us with their amazing talks that they prepared so hard for. I mean, if you got here early, you would have seen them doing some practice runs and getting amped just to ensure that you guys have an awesome evening here tonight. And that's what we want to ensure we do for you. So thank you again to all our sponsors. Thanks for the amazing food, and thanks for the beautiful venue. I think we're going to have an awesome time tonight, and I'm really looking forward to connecting with everyone, even afterwards, after the talks. There's lots to look forward to this evening. So, without further ado, we're going to start off with Tim, who's going to actually talk about rendering strategies. He's a full-stack developer from Passionate People, and he loves creating digital things and combining his love for design, typography, and development in general. I asked Tim to share one of his secret resources with us and upcoming developers that he sees on a daily basis for inspiration, and he mentioned Site Inspire for his source of truth. So make sure you go and check it out. But without further ado, let's give Tim a warm welcome.
Cool. Thanks. All right. Hello. Thanks for being here. Yeah, so rendering strategies, let's get into it. That's what we're talking about today. We're gonna start out with like a little tour through the history of it, like see what the trends are, and also what we learned from it and how we can hopefully inspire to like make adjustments in your day-to-day like decisions, like when should we use what. Yeah. Already got an introduction. I'm Tim. Most of the time I put etc. after my name because it's way too long. Like to do triathlon, training for one next year, so that's also really cool. I started building websites back in 2001-ish, I think. So it was also cool doing this presentation, doing the preparing, and yeah, see what all the things like back in the day were and like where we at now is. It's really fun to see. Yeah, I'm a consultant at Passionate People, and I think most of the people here do React, but yeah, I'm using Svelte and Angular most of the time. But I like how we learn from each other and how we put those learnings and you see Vue learning a lot from React and the other way around. So it's really cool what's happening nowadays, I think. And yeah, you can follow me online as well. Looking for friends on Twitter, a bit late to the game. So if you're looking for friends as well, add me. Yeah, let's start with the history lesson. This guy, Tim Berners-Lee, the legend himself, that's where it all started, of course. Back in 1990, so it's a long time ago. Mostly universities went using it. It stayed like a, yeah, it was a simple concept, of course. At the time, it was really advanced stuff, but nowadays it's a simple concept. And yeah, you had to be tech savvy to actually take part in it. But that's where it all started. After that first hype, we got the backend hype. So like the first server rendering happened also in the 90s. I was looking up when PHP started, and I was surprised that it was like 1993 when he actually started working on it. It started like a templating engine because working with C was too difficult, and he was thinking, okay, we should make this easier. And that's how PHP got started. But that's also the first server-side rendering, what is a hype again as well, especially for the front-end scene. And also a fun piece of code for maybe people who are working on web stuff for a long time. Server-side includes. It was a way of putting HTML with dynamic stuff. So it was just as HTML elements, like documents. And the server, like in this case Apache most of the time, but Nginx does support it as well, puts it together and sends it back. So yeah, that's how it all started. And like you see on the over here. So that's where also all the work is. And like the client doesn't do a lot. So back then it was also good because like the browsers could make use of it right away. One thing, one thing that's came afterward. Like I thought this was older than PHP, but it's the other way around. Frame sets, you don't see them often anymore, but they're really cool. You can attach windows to each other, so you have like multiple, documents like URLs, and you can stick them to each other. And that was like the first, okay, we have backend, let's go back to front-end approach, because like if you're building bigger websites, like websites got bigger through time, you don't want to make the navigation 20 times if you have 20 pages. So like one way to solve it was backend. The other way to fix it was like iframes, frame sets. And yeah, you could make a header, a sidebar, and like the main thing. So if we're making larger websites, you could easily maintain them. And yeah, you sometimes still see them in like old apps, but they're deprecated, so you shouldn't use them. The hype after backend became caching, because we're making like WordPress kind of websites, like there's PHP, and every time that a request is made, you had to build the page and send it back. So when you have large amounts of people, that's gonna bottleneck. So caching was built to make sure that there was like one page being processed, it was made, and you could put it in cache, and every time a new client would ask for the same page, you would serve that instead. And it's actually a pretty old hype. Like it started in the end of the 90s already. Like in the 2000s, it got bigger, and it helped scale the popularity of web. So it did, it was a real game changer. The downside of it is, of course, if you cache something, you have to serve it out again. So if you have like dynamic parts of a page, you run into issues because you cannot like account for those. So it has its limitations. And this is also a nice one. Ajax. It was like, I think, the first like really big hype. Like everybody, like Web 2.0, DHTML, Ajax was like a really thing you would see in all the blogs. It was raiding on the HTML hype as well, what was pushed by Internet Explorer at the time. So that says a lot. But it took a real long time before it was a spec which we can actually use. So it was first an ActiveX element. It was a proprietary part of like Internet Explorer from Microsoft. So it was first introduced for making Outlook, doing things for Outlook. And years later, it was actually a spec, and it got big with jQuery as well. So that's also the snippet you see here. Make an event listener, do an HTTP request, and put that result back into the document. And that was, yeah, really cool because especially Gmail did a lot in this. Before this, you always had multi-page applications. So every time you clicked a link, there was a new page. You would see like a blank screen, and then it would load. And when this was introduced, you could click or type, and something would happen, and the rest of the application stayed the same, and you would have like a more connected feel. So this is a really big step in history, I think, especially for web and JS, of course. It made also this step possible. Single-page applications, SPAs. A few years after, jQuery also Knockout did the most, and Angular was also pretty soon after that. And they introduced the real dynamic stuff, which is also 12 years ago already. Last week, I think. And they had routing, so you could do transitions, keep state, the component way of building things. So we had BEM before, and like other ways to organize your code. So you would have some consistency that what belonged to each other and like how to reuse it. But these libraries really made the component way approach possible. And two-way binding was also that's also the example here. That was also a big thing for Angular, a selling point. And this is where it all started and what we are still working with today, of course. After that, a little bit before, Jekyll was pretty soon, but after that became the real hype. So we just moved everything to the front end, right? To the front end. So what you see is the client does all the work, and now we're getting back to, okay, we're doing everything in CI, and you could serve it on CDN. So make all the content, collect it, build the static HTML, and push it onto a CDN and serve that. And it's really safe and secure, of course, because there's nothing to hack. It's just static files. But it's also cheap and fast. Also with the same downside as caching. You cannot do a whole lot with like dynamic stuff. If you want like personalized items on there, it's hard to do that. And for larger sites or sites that have lots of content, like fast-paced changes to content, you probably want to look into ISR, incremental static generation. It doesn't fit, but yeah, you know what I mean. So yeah, that was coming after the fact, but it started with static site generating, and it's still a big thing. I think it's used still a lot. And yeah, server-side rendering is like after that again. You wouldn't expect that, but yeah, Next did a lot in that scene. Nuxt came at almost the same time. Angular was a little bit later. Svelte is also still working on it, building to their 1.0 still. But yeah, there's a lot of meta frameworks building on top of those libraries and get those front end things we like, those component way, that component way of building, and get it back to the back end. And that's also nice because if you can get more logic to the back end, you have to ship less to the front end. So the server is taking over a lot of resources from the client. And one benefit is SEO, for example, because you have static HTML, it's really easy to parse and to get into search engines. Downside of it is hydration. Especially with full page hydration, you will have to do the work 2 times. So at the server, you're parsing everything and you're shipping it, and then the client have to do it again and replace it to make it interactive. Recently, we got Edge for sales, also pushing that with Next, of course. Netlify, Cloudflare are working hard on it. WinterCG is something that's announced the year before, which is more like a collaboration to make sure that we build one ecosystem, so you don't have one specific vendor that you could use, and also with all the different nodes, you can now also use other executables, of course. So yeah, that makes it easier to make it one ecosystem. But what what they try to solve with this is to make a server which maybe serves data or manages the data and do the actual processing near the client. So if you have a global app you're making, you can render the pages close to the user, which should add less latency, make less latency, and you can make very dynamic pages. But yeah, you also have to make sure that the server, so in your database or something else, is still near the edge as well. Because if you have one database in the Netherlands, for example, if you have edge nodes all over the world, you will still have latency to the client, because yeah, your database to the edge nodes will be further away. So it's not a silver bullet. But yeah, what is really cool, I'm currently diving into this more. I'm working a lot with Astro lately, and the cool thing about Astro is it's framework agnostic. And what you can do with it is building island architectures. You can use Fresh as well. It's React only, and you're able to only use React. With Astro, you do need Astro components, which are not real hard to get into. You see an example here. You import it, and you have HTML below it. But you can use React, Vue, Svelte, whatever you want. You can use it in Astro, and you don't have to choose one. You can use all of them. So you can mix them up. One component could be React, the other could be Vue. That's fine. The powerful thing about this is that it brings multi-page applications back, and multi-page applications are pretty flat. You have CSS, you have HTML, and you can static site generate them, or you can server-side render them. Both are supported by Astro, but the end result is the same. And the powerful thing is you can make, for example, a search bar. You can make it interactive. So in this case, you would probably do it on load, but if you're on a search page. But there's all kinds of strategies you can use. For example, client idle, it will wait for the browser to be done loading, and if it's done it's done everything, and it's just waiting for instructions, then it will do loading. So yeah, you can load things that are not necessary for the first view, And with visible, you can, for example, do interactive elements that are lower down the page that are not needed right away. So it will be fetched from the server and rendered later on. And you can also do things like client-only React is, for example, a really cool thing that you cannot, it will not render on like the static or like the server, but it will render just on the client. So you only will have the interactive element and you won't have like the DOM right away. The last one is also pretty cool, the max width. So if you have like certain viewports that shouldn't load parts, you can also do that. So you can have static sites or server rendered sites, but only make the components interactive that you need to be interactive. So for lots of sites, most of it is just static, right? Unless you're building apps, of course. But yeah, in that sense, it's really powerful because you can leave a lot from the client, and that's also what we're now seeing. Also, this week, of course, with React 18 and Next 13, there's really cool stuff with layouts, server components, and streaming. It's still very different from Quick. Quick is trying to minimize everything. So what it does is when you click something, it will fetch the script, get the bundle, and it will do its work. And you can server render that stuff as well. React is still loading, like you have still like a big chunk of React. But with for server components, what you can do is make instructions go to the server, let it render, and get those instructions back, and React will render it on the page, which is really cool. It's like we had Ajax like a little while ago. The only difference is it's instructions for React, and it's not like HTML or something you're streaming back. But yeah, there's a trend of less bundles, smaller bundles, and also you can move pretty big chunks of computation back from the client. So also when you have clients that don't have a lot of power or that kind of stuff, or like your internet connection is really bad, so you don't want to ship large bundles with like dependencies, you can all leave them on the server, which is really cool, and you can do really powerful stuff with those strategies. So that's where we're at now. We had a lot of different strategies through time, and we're all trends, but they were all chasing performance. But they did a ping pong between like, let's take things to the front end, no, let's put them back to the back end, and like back and forth. But there's like no right way to do things, and we can also see it more like a toolbox. So you can see, okay, we have this project and we have these specs and we need to do like a certain thing. So what is important for us? What is like the context? How is our infrastructure looking? And what do we actually need? So have a look at what is important for your project. And there's like some things that are always the same, of course. We all want lower costs, and lower impact on the planet is also a thing, for me at least. If you have like less computation, also with like doing things multiple times, it's using up a lot of resources, and that's not a good thing. But and we get more performance for that as well, because if we have less computation needed for every request, we can get more performance out of it, which leads to happy users and in some cases also more conversion. And I just got this from the Astro website to demonstrate how much it can make a difference. So things to consider is like how much content do you have, and what, like how many times does it change, and where is it stored, and also where's your user base. Like edge computing, for example, is really fun, but like if you're only serving the Netherlands, like edge computing in the Netherlands, it's not really useful. It's a small country, so it's yeah, it's not getting closer by the user. Yeah, maybe fun to do some examples and see what we can take from these strategies. So, for example, we're building an analytics dashboard. We want to show data because otherwise it's not really useful. And CEO is not a thing for dashboards, of course. Real-time updates is maybe important because it's changing a lot and you want to be on point. Maybe the best point is to go to an SPA because you can host it on a CDN. It's quite simple. But also real-time updates. If you do server-side rendering, it's really hard because you have to get it from the server every time. So you have to poll. It's not really easy to do that. So in that sense, I would pick an SPA. If you have like a big corporate website, you have a lot of pages. Performance is important also for SEO, because if your performance is on point, SEO will be better. And if you have global visitors, you also have to make sure it's close by. So in that scenario, you could use static site generation and host it on a CDN. And CDNs are most of the time distributed. So you have like multiple things solved right away. If you have a large website, or if the content is changing a lot, you can check the incremental generation, and or choose for like the SSR approach, do like the server-side rendering on the edge and maybe cache it, and then it will be quick as well. The island architecture is also something that I like a lot. If you just need like one small thing and the rest is static, if one thing like an account login, like a name, yeah, you can do that with islands as well. And then you have almost no JavaScript shipping to your clients. And restricted pages, also with Edge, you can do a lot. You can check cookies and all that kind of stuff. And you can just show another page. You can do rewrites in the Edge URL, rewrites, and it will just show up another page for maybe people that are not logged in, or like a paywall. You can think of all kinds of things why you would want to do this. A web shop, performance is money, of course. SEO is also important, but you have a lot of more reactive elements. So maybe you also want to do tests, A/B testing, for example, see how you can get more conversion out of it. In that, you could still do like static site generation with islands, but if you have more dynamic parts in your design, maybe SSR is also better. You can do like more things like recommended items or other kinds of things that push sales. But what you can do with the island approach is load on view. So if things is in the bottom of the page, you want people to be able to see the product right away and be clicking on it, like I want this in my basket and let's go. So you want it to be interactive right away. So if you can load stuff in view, you probably want to do that. A/B testing is also something you can do really well on the edge. You can swap two different versions of the website and test which one scores better. And like I said, if you're doing a global thing and you're using Edge, make sure your data is nearby as well. Social apps have all kinds of different other, they're way more dynamic, way more personalized. So in that way, you probably also want to pick like an SPA or something that just fetches data and renders it. Maybe make it progressive web app. SSR is also a good option, especially the React way we have now. Because low-end devices, for example, if you're having India or Africa in your target audience as well, it will move a lot of computation to the server. So like dumb phones, for example, really like this. Like if you can keep it minimal, it will work better. Yeah, and you probably want to use edge functions for it as well. Documentation side is a perfect example for islands too. You can do search really easily, and like for a documentation site, you probably just want like the content, and it doesn't change a whole lot. And you can do nowadays a whole lot with CSS. So if you have like scrolling to the certain part of the page that holds the information, so you have like a page index. Smooth scroll is just like a CSS thing now, so you don't have to ship a smooth scrolling bundle just for that to work. So sometimes it's also good. There's also examples from Steve from Builder.io. He has like a carousel just made with CSS with snapping points. It's really cool. So also check out CSS and what you can do with it. It makes stuff a lot smaller too. Project management tool. This one is mostly in it for the glitchy connection. Server-side rendered apps are really cool, but they're also a pain because if you don't have a stable connection, every interaction will take a long time or will not work at all. So if you have a part of the page that is really important and you server render it and you know, for example, with a planning tool or something, people are on the road and they may not have a stable connection. Maybe like an offline first approach could be a thing, or there's like different ways to solve your issue. But yeah, the main takeaway from me is like there's a lot of frameworks. They're learning a lot from each other, and through time we have a lot of things that we tried out and what we learned, and there's really specific cases when to use them. And it's really cool also to see all the different frameworks to learn from each other. And like also Next, if you check how much you can do with it, how many different strategies you can already do just within Next. Yeah, I find it really cool, and I hope to see also more collaboration in that. Also with Astro and React, it would be cool to see them collaborate more. Yeah, that's it. Thanks.
Thank you so much, Tim.
Yeah.
It's really great to see how far we've come in the front-end front. It's almost full circle, I should say, from the past. Unfortunately, I'm one of those developers who had to work in IE8, and yeah, brought back some bad memories there, Tim. But some people call us developers, some engineers, some consultants. What I like to call ourselves these days is a front-end chef, because we have so many ingredients that Tim mentions that we can cook up a great recipe for our clients, for our employer. And yeah, it's really a great time to be a front-end developer. But moving on to our next talk, let's talk about end-to-end. Is this the end of end-to-ends? Drama. Tobias is a developer from ING Belgium, currently living in Amsterdam, and he's a flock engineer who's been a lead for now 3 years at ING. And he loves to play a good game of snooker, Factorio gaming, and digs a good Futurama quote. One cool thing that he shared with me today is that even if it's a bad email, whenever he sends it out, he says, "Good news, everyone." Ladies and gentlemen, welcome, Tobias.
Good news, everyone. Or should I say good afternoon? I think, yeah, you need it. Just like that. UC code, which is something we get there later. For now, I just share this. So it's great to be here. It took quite a journey. I don't go into far details, but it was kind of an experience, let's say. So I'm super excited to be here, and that you are having me here as a guest. So another really exciting journey. It's been a couple of years ago when I was 18, 20, I don't know, I don't really recall, but I went to London. And when I went to London, I planned everything ahead, right? So I would just book my flights, and because I thought like I'm a cheap bastard, I booked the cheapest flight. And the cheapest flight are mostly located in the morning. So I went there Saturday mornings. I had to go back Sunday mornings, which was also a good thing because didn't have to book a hotel. So also cheap. Looked around the city. In the evening, I went out having a couple of beers, did some pub crawls, and you know what they do. But in England, what they do is at 3 o'clock in the morning, they stop. They stop. And yeah, well, you get thrown out of the of the pub when you have the most fun. Yeah, it's a bit sad, but it happens. And so I thought, like, well, it's a great time. 3, can make it to the airport on time, no problem. So I went walking to the nearest tube station, and I realized there's a gate, and the gate is locked. And I rambled. It's like, oh, the gate is really not opening. And I thought, like, yeah, maybe this particular station is under construction, maybe. So I thought, like, yeah, maybe I just walk to the other station. It's just not so far. But turns out London is a big city. I took a wrong turn somewhere. It is 3 o'clock in the morning. I had a couple of beers. Didn't really work out. Took me hours to get there. Just to realize there's also a gate. It's also closed. And then I just probably recalled, like, oh, maybe they're just not open. And I waited. And I waited for 1.5 hours until they finally opened the gate and I could take the tube to the airport. Well, during my travels, I also realized the tube is not the fastest transportation you can take to get to the airport, so I was short on time, like way short on time. And Heathrow is a huge airport. So I got into big troubles to get my boarding pass, which on this vending machine doesn't really work, and then I was typing it, I was punching it, and it was not really working. I went to the counter, asked, can you give me my boarding pass? Well, in the end, what happened was they didn't give me my boarding pass because I was way too late. I didn't make security, and I had to rebook for a huge amount of money, and finally made it back, but it took me like 16 hours to get the new flight, so I was way late and lost a lot of money. But brings me quite an end-to-end story, right? I just went from one end to another, and it was just all of this. And then you think, and I see some people thinking, why didn't he take a taxi? I mean, what's the big deal? You just pay 50 quid, you're done. You're just on time, and you don't have any troubles. And that's kind of basically what I want to talk about, the easiness today, which you can have with end-to-end testing. And kind of the easiness, you just take the high road, just take the taxi and just don't be really confused about things and just try stuff which didn't work or doesn't work, or just, why so complicated? Right? Just make it easy. As introduction already said, my name is Tobias. I work at Flock as an IT consultant and 3 years as a tech lead at ING. Currently, well, under contract in Belgium, but I also had like 2 different projects in the Netherlands. Was consulting the whole build-up and the whole architecture of the product we are building. I'm a full-stack developer, but mostly focused these 3 years on fully on front-end based applications. And at ING, we build everything in lit element, which is kind of a web component-based library. It's quite fast, and it's quite nice to work with. But it's not the only framework I worked with and I can work with. So I just also used all of the other stuff which you just saw in the previous presentation. I played with Angular, React, and I want to play a bit with Quick, but that's on the side. But my backend, well, in the backend I just like to play with the typical Java Kotlin combination or Python because it's super easy, right? But now it brings me to these questions. To this one single question. Why actually do we write tests? Why do we take so much time and write something to just confirm that it does what it does? And that's actually the only reason why we do that, right? We write some code and we want to know with confidence, we want to say with confidence that this thing, this piece of code we wrote is exactly behaving and doing what we like and what we want. And if we do a change, if we change the code a bit, we also want to be ensured that we don't break what we already have written. So it's kind of even more confidence boosting, right? We want to make sure this piece of code works. Even though I just changed something here, this piece of code still works. And that's the whole thing why we do testing. The thing what we have now, though, is we have front-end applications, because we're a front-end meetup. So we have front-end applications, and they do a lot of communication. They not only communicate with the people which interact with these applications, because, well, we build stuff for users which type stuff in, and that's kind of the input we get, and then we process this input. But we process this input only to an extent, because, well, we send it somewhere, because we don't own databases. We have to send it somewhere. So there's another communication which we do with other services. And this communication, we just provide the data or whatever we want to do, or we get data from there. And that's kind of the interaction we have, one side and the other side. And that's where actually end-to-end integration testing comes into play, because that's the testing we want to do to get our confidence up. So we write end-to-end tests to just check if the communication between these services are still working as expected, and that our application is responding also as expected. Over the years, we transformed from big monolithic applications into somewhat smaller applications. Some might use micro frontends in the backend, of course. But some of you might also, and ING is kind of pushing towards micro frontends now. So we even get smaller pieces which have to interact even more. Because the front-end application you're building is not only communicating with the user which is interacting with it. No, it's actually also interacting and communicating with the service or with the platform they embedded in. So you have another layer of communication. You also probably need to test and validate that this communication is also working. And because of the monolithic the non-monolithic structure we are now used to, we might also consume multiple microservices, not only one. So it adds a lot of complexity already. We have already a lot of complexity, and then we want to, well, add integration testing on, or end-to-end testing on it. And that leads me, if I may ask you a question, it's like, who of you really enjoys writing end-to-end tests? With a raise of hand. Wow, you're weird people. Okay, but that's fine. But it's like even for the people who are watching online, it's less than 1/3 of the room. It's maybe 1/4 or 1/5. So that leads me back to the end-to-end testing didn't change, because we still perceive monolithic structures and monolithic principles onto our end-to-end testing, because it's a single production-like environment where we deploy the stuff. And we have to make sure that everything is deployed in the same time. Like our microservices we want to interact with, they need to be deployed in a single prod environment, as does our front end. And when we test this whole thing, when we run all of the battery of testing, then the thing we want to make sure is we can only publish or put that thing to production, this snapshot of this single prod-like environment, because that's the only thing we tested. We can't just change a microservice and say like, oh, cool, we ship that to production, because we didn't run the battery of end-to-end tests against that thing. So it's very limited in that sense. And it, well, becomes fragile, and flakiness you get with it, because sometimes tests just fail. And then we have to look and inspect why, or rerun the test again and then see, oh, it's succeeding now. So you get like these little nuances of weird errors which you have to investigate. And sometimes they fail because you take the wrong data in the testing environment you have. And then you just fail. And then you have to investigate again. See, why did my test fail? Did I break something with my change, or where is this coming from? And well, the same thing holds true if the microservice is deployed in a different version you expect it to be. Or maybe they broke something with the new version, but you don't really know. So that really leaves you, or us developers, as this uncertainty we get. The question we have is, where's my confidence? Because I lost all my confidence in my product because I can't ship it. Because I think like, oh, did I break it with the wrong test data I put into the environment? Did I put the wrong test data in the environment? I don't know. But my confidence is gone. So the whole idea of relying and breaking that confidence into my domain is just vanished. Then third item is that it's really slow. I mean, you have to imagine, yeah, right? You're running all of these batteries of tests against the real deal, against the real service. So you call the real microservice, you send the data actually to that microservice, which has to provide and work with this data, put it to the database, which is a real database, and then returns all the data. So in the end, what you get is a really, really slow and complex thing because it can break. But it also takes a long time to write these tests and even longer to maintain end-to-end tests because, well, you write a new feature, you have to update your end-to-end test. If a microservice updates and you consume it and it changes something, you have to update your end-to-end test. So you're constantly actually writing tests. But we all know we don't really want to do that. And if something really breaks, you have to investigate and you have to debug. And where do you start? Well, probably at your side. Then you realize, well, one of my microservices is failing. It's not in my domain, so I have to call someone, I have to communicate with a team, and I have to ask, can you look into your logs? Can you tell me what you see? Is there something broken? And they probably depend on another microservice which talks to the database, and they say like, yeah, it's this microservice. So you're constantly talking to people and try to communicate and figuring out not who's to blame, but how's to fix this problem. And well, yeah, in the end, you still put so much effort and work into debugging this thing that you forget to build some other stuff. You can't because you have to fix it. Leads me to this. Because let's be honest here, if we have the possibility to not write tests and still get our confidence up in our software, we would prefer this, right? We don't want to do work when we don't have to, because we're lazy developers in the end. So let's see, if I say, we can do this if we follow two things, and if we look back at the testing pyramid, everyone knows it, everyone has seen it. And the nice thing about it, the testing pyramid, is in the bottom you have the unit tests which are part of your domain, and the integration, the end-to-end tests, which take a bit longer, and communication with other teams, it's not fully in your domain. So what you want to do, and that's why it's the biggest chunk, you want to keep the most tests in your domain, because it's the easiest one, the fastest, whatever. But we can add one more layer, I think, because it's just mistaking. And that's the layer it automatically added. Okay, it's the type safety. Because with type-safe languages, you get this immediate response, fast feedback. It is in your code. It is actually in your IDE, where you get these quirly underlying things which says you can't use this property on that object you're gonna use. So you get immediate responses and immediate testing, basically, for nothing, for not doing anything. And even it goes so far that it sometimes recommends you from, hey, wait, this object can maybe be not there, so nullable types. Do you have something for it? Can you prevent breaking your code? Which is a nice thing, which is kind of testing, right? And it gives you confidence for literally nothing. And the second thing is where we want to watch it is the communication between our front end and the back end. In this example, there's just one backend, but it doesn't need to be, because it could be multiple. But if your front end makes a call to the backend, it gets a response of data. In this case, because it's a bank, you get an IBAN and an amount of money on it. And here you can clearly see that, like, well, that's the data I can handle. But you don't really know what you get back, because it could be that there's a change in the backend, or something else happened, or the amount gets a string instead of a number. And then your front end would break it, because you don't count with it. You don't think that these changes can come around. So what already exists is these API contracts you can use. It's the Open API spec, or Swagger also called. which exactly tells you what to expect from a backend service, right? Because that's the API the backend service is using, right? In the best case, right? And they say like that you can expect, if you make this GET request, you can expect a response which contains an IBAN, which is of type string, and the amount, which is a number. So you can 100% be sure that that's the data you get. And that's a bit of the single source of truth is in this API contract. And you can take it for granted that this will work, because otherwise it wouldn't be in the spec. So if you combine the two, this API-centric principle or this API spec and the type-safe languages, what you can do is you can generate types based on that contract and then use it in your code base to guarantee everything is working fine. And I have a short demo for it. And I hope, because it's a live demo, it works actually. We'll see. Let's go there. So that's the code. First, this is the application. It's a very simple application. It's a bank for animals, for your favorite pet. And they have money, they have an account, and you can probably manage the account, but it doesn't really. And here are some of their most famous transactions the last day. That's all that the application does. And it gets the application gets the data from the backend, of course, because it doesn't do any own data transformations. And that's this one I'm going to show you now, this application. I'm going to show you now how you can run a battery of tests against it to verify that it still works with the backend, but also how we can change that with the API contract manner. So let me get into the code. I built this in lit element because ING builds in lit element. So I just quickly go through. This is the main component. And as you can see, here's the service I'm calling or instantiating. And here's the get account I'm just getting. And because I just have one customer at my bank at the moment, it just gives me one customer. And then I just probably start the whole So just get me the application started. And then I run the test. I use Playwright to run the tests. And in 3 seconds, 4 seconds, it says it passed. So everything is good. That's fine. That's nice. So now I go into the database. And just change something. Run the test again, see what happens. Still goes good. I have to restart the server. Should fail. Nice, right? These demos, always. I split that one. Can I run this again? Just make sure that it's actually it's a different amount now. And now it's failing. Yeah. See. So this what I just mimicked is wrong test data or change test data, because you deploy in one single prod-like environment, someone else can also access this test data. So they can manipulate it. And out of some arbitrary reason, your tests, which actually should have gone right, they are failing. And you have to go like, what happened? Is my application still good? Yeah, it's still good. But somebody just messed around with test data. If I shut down the server and run a battery of tests, well, obviously what happens? It fails, because the server is not really there. It's just offline. Also something which is not part of your problem, because your application still is fine. Everything is good. Everything is working. But the tests are failing. So it gives you a false sense of negativity, of wrong. And now if I just call it account balance, restart the server, and then run the test, it will also fail, but now for the right reason, because something changed. Your application wouldn't work in production anymore because somebody in the backend or database changed the attribute, and you're receiving the attribute is not correct. So if I have this Swagger API from the backend right here, and it says every property it contains. Now it contains still the balance. I will just change that back in the database in a moment. Where is my database? I closed it. Yeah. I just change that back. Account. Balance. So change that back. Keep it here. So if you can see here, everything is defined clearly. So you have a clear contract. Everything is here in this document. And when I just what I can do now is I can just generate a contract or generate my types from there. So I just have to look what kind of command it was. I think it was this one. Yeah. I just run this one quickly. So now, like some external tool I'm using is running and is creating me this TypeScript file, which if you look, you can see everything back, like the ID, the balance, the account number, and all the types there, because well, it just generated it from. So what I can do now, I can go back into my code and look at the account service here on the right, and see that I just, because it's plain JavaScript, it's vanilla JavaScript, but you can still use the TypeScript compiler to actually help you with the typing. With the JSDocs string tags, you can just use it there. So you don't have to fully rely or fully write TypeScript to get type safety. You just use the TypeScript compiler in your development time. So what I did here is to just say that this, what I can expect here as a response is the accounts detailed response body. So I exactly did what you see here. I can expect that here. And because I can expect that here, I get also these nice things when I just do now account balance. It just turns red and says like, yeah, it doesn't exist. You can't use that. So it prevents you actually from making mistakes before you actually run a battery of tests. You don't need to write tests for this. It's given. It's for free. And if I do the change now and bring account balance back and regenerate npm run no, it's the other one. I quickly look. Swagger JSON, Swagger JSDoc. So now I just run this command to generate it, so it should refresh. Should it? Nope. Why not? Oh yeah, I didn't change it. Didn't change it in documentation. It's a bit tricky to do. Oh crap. Account number, account balance. And then regenerate that. And then regenerate my types. I can see that my account balance is here. So it changed. And now if I go into one of these files to actually activate the typing, bear with me here. This one. And then bring that back. Here, I've got red. I don't need to debug. I don't need to call third parties. I don't need to call anyone. I just get instant response like, I just regenerated your backend and the contract we have, and I get immediately response that, oh, something is wrong, something changed, and it will break my application. I don't need to run a battery of tests. Again, no tests. You get it, all for free. Huh. Unhandy. So that concludes my live demo. So what is here now? What's the lesson learned? So actually, we need to request this API contract from our backends, and if they don't provide it. Otherwise, we can just easily just take it and take it for granted and just remind the backends that they might have issues or problems or not really good documented contracts because something breaks, because we can easily test that. And what I did show you here in my demo is that it's backend driven, because my backend, I had to change something in the backend in the documentation to generate that API contract and to take that as single source of truth for the front end. But that's not ideal, because, well, we all front-enders, we like front-end, and we don't like the backend that much. So what if you take API first design? So you take backenders and front-enders together, or not, depending on the size of the backend and depending on what microservice is serving a lot of customers. You can't take all of customers together. But let's imagine here we have just one front end and one backend. We put them together and design the API contract first before implementing. And then the backend goes back and says like, okay, we're going to implement that API spec. So you are 100% sure that they're actually implementing it and that you can take it as single source of truth. Both can do, because both agreed on that single signed contract with all the benefits it brings. If you go in the front end a step further and introduce something like inversion of control, what you can do is you can have a live service layer, which is actually communicating to the real backend, and a testing service layer, which contains mock data. But this mock data is not any mock data. It is typed mock data, because you can use the types as well there. You can just say, be of that response, and then they will be of that response. They will be exactly the same response you get from the real API without leaving your domain, because mock data is within your domain. So you take these whole end-to-end tests, which are just way up of the pyramid, and take them all down and make them kind of unit tests, because you take them back. It's fully under your control. So there's a recipe for success. 3 steps, right? You get this API contract. You generate your types, and you profit. Simple as that, right? Because yeah, everything you saw in my demo as well, it's all there. So you don't have to write anything. You don't have to maintain anything. You just take it as for granted, because it's just there and it's 100% the truth, because you rely on it. And you know. Which brings me back to London. If I knew the taxi back then, because I didn't think about it, I would have saved a lot of money. But in essence as well, I would have taken a simple road. What I showed you here is super simple, because you just generate the stuff, plug it into your application, and it doesn't break anything, because it doesn't change anything. It just adds types. And as you see, plain JavaScript can be used as well. And with that, if you don't like it or you get too many red circlings under things, you just throw it out again. You don't break any functionality. So it's kind of a free deal. Just go out and try it. Don't like it, toss it away, and nothing will break. Yeah, and with that, I will I will leave you. So thank you very much for your attention.
Thank you so much, Tobias. I must say I was quite intimidated there with that end-to-end question, but you made things so much simpler for us to understand. Thank you for doing that. I'm definitely going to be trying and asking my back-end developers for a contract, because I really feel that development is a marriage between the front end and the back end, and your contractual obligation there kind of really saying that you're in tune for me. But right, I think everyone is ready for some refreshments. So why don't we all take a 20-minute break, and I'll see you all back here very soon. Good evening once again. Nice to see that we didn't lose anybody. We have got some good feedback so far about this meetup, and it's really positive. So keep that feedback coming. We always take it to heart. Once again, thank you for being here. Hope you had a good drink. And we're going to move on to our next speaker, Matias, who is an information system engineering graduate and has been a front-end developer for 9 years. And he's currently at ING as a freelance developer. He loves JavaScript-related technologies, board games, and video games, and a really cool quirk about him is that instead of fairy tales with his 5-year-old daughter, he plays Dungeons and Dragons, and they both slay dragons together. And I think that's really cute. Let's welcome to stage Matias, who's talking about event-driven dependency injection.
Thanks. Back when I was in college at the Technological National University on Cordoba, Argentina, I was on my last year of the university, and still I didn't knew if I really liked the career. Yeah, it took me quite some time to figure that out. And then our mobile application teacher asked us a question. How do you, in an Android app, pick up a file from the disk and show a progress bar to the user? And he stayed there and wait, and no one knew the answer. So then he said, okay, I will give you a clue. You are in Android, and Android is Java, and Java is single-thread application by nature. And yet, no one replied. So, sorry, technical problem right here. There we go. So, of course, he was upset. He was so upset and so disappointed to all of us, all junior students that doesn't know something. And he was telling us, you learned these things on your first year here. How is it that you don't know this? You have a single thread rendering your screen. You make that thread go and read something from the disk. The thread is not going to render the screen anymore, or is it? Right? So you need to fire a separate one. So he started explaining how do we solve the problem and what we should already know. And everyone was very ashamed, of course, including me. But right there, when he was telling about all these like basic theoretical concepts that we already know, we learn, is when I realized, oh, I can use the basis of what I learned to solve problems. That's engineering. Eureka, I like engineering. So that's how I fall in love with it. Oops, sorry. So more technical problems. So I was already introduced. Thank you for introduction. I'm Matias Fernandez Martinez. I have 9 years of experience doing front-end applications. I worked back in the days of jQuery. If you remember those days, you were not lucky. Also work a lot with Angular, and the last couple of years have been working with lead elements for ING. Some things I like, you already know. I like role games, video games, and I like to play stuff with my kids. And I also like JavaScript powered things, like my smartwatch right here that failed me at the beginning, but now it's working. Yay! So let's begin. The topic of this presentation is, the name of this presentation is event-driven dependency injection. So this is just a fancy name, like over-the-top name, for a very simple concept and presentation, so don't expect too much of it. What it should be actually, what we are going to be actually talking about is dependency injections on custom elements. So these are the topics we're going to see. Does anyone have work on a side project on their regular work with dependency injection? You can see any hands. Right? Quite a couple of people. And has any one of you worked with custom elements? Even less people. Oh, even more. Yay, ING, go. So don't worry if you don't know one or either of those. We're going to quickly review them. And then we're going to check if there is any conflict happening between these two technologies. So dependency injection. What is a dependency injection? Typically, when you have a function or an object and you need something to make it work, you just instantiate that. But dependency injection says that you should not create your own instances. This should be pushed through you to you with a setter or a constructor in your constructor. So when we are talking about dependency injection, we need to review a couple of concepts. One is that dependency injection is a design pattern. It's not a specific technology. Then what it means that your object or functions will receive the objects or functions that needs to function properly. And the other concept we need to revisit to see a little bit is called inversion of control. Inversion of control means that the flow of your application is inverted. Your custom code is not calling pieces of your framework, it's the framework the one pushing things are calling your custom code. So that is what it means. And this implies the tell don't ask principle. So you have to declare what you want, but you don't state how and who, right? So when I was back in college again, I studied this concept of dependency injection, and I had a trouble with the term. And I have two quotes for you to share. One is a good quote. The other one is not so good, so please don't be very disappointed for it. The first one is $25 dollar term for a 5-cent concept from James Shore. He wrote a very nice article called Dependency Injection Demystified. And the second quote is a setter with bells and whistles. You can quote me on that, of course. The reason why I was so frustrated with the term is because why do we need such a complex name that brings so much attention for a very simple concept underneath? Although it is a simple concept and it's a fancy name, just as this presentation, it is very powerful. So simple doesn't mean easy to implement, and also doesn't mean that it's not powerful. So with dependency injection, you can decouple your code. You can create the scope implementations, so your application can take a dependency that is using a certain file system, and you can swap that file system for another one, and your application will still be working, and it's not aware of anything changing. You can also simplify your runtime configuration, so if your APIs are depending on an event or an API that is also your control, it can make the configuration of those dependencies a little easier. Of course, it helps with testing. This is one of the primary things why you want to do it, because you can mock these dependencies way easier because of all the decoupling we did. And also, you can override behavior. So the same strategy we use for the mock, for mocking dependencies in our test, we can use it actually in our application and change the behavior of it. So now that we saw a little bit of what dependency injection is, let's talk about the custom elements. So a custom element basically is a way of isolating your logic into a small custom HTML tag. So what it happens is that you need a class that extends the HTML element class, and then you need to declare that as a proper custom tag. So custom elements are very simple underneath. The browser just sees a tag that is custom. It looks for it in the list of custom element definitions, and then instantiates that. One thing important here, if you look at the code, those two slides, is that there is no constructor call. So it's the browser the one that is constructing this instance. So there is no new statement, no other way to actually get an instance of that element, rather than the browser being the one creating one for us. Now that we know both concepts, we can talk about what is conflicting here. Why cannot or can I use dependency injection with custom elements? A dependency injection relies on a container because the container is the one calling the constructor and passing down parameters, right? Those are your dependencies, your services, your factories that you need. But a custom element is instantiated by the browser. So you have no control over the constructor. The browser calls the constructor with nothing in it. So how do you put a service inside your custom element? Well, you can't. So all this presentation is a big bluff. It actually should be called dependency resolution on custom elements. So let's see how come we actually achieve the same goals, get our encapsulation, decoupling with custom elements and with a simple system. This is not for a framework. This is not, oh, let's just use Angular. No, this is just bare HTML technologies. So in order to resolve this problem, first we need to think about it a little bit. We need to communicate our custom element with a provider, right? And the provider needs to pass down a dependency to this custom element. Now, other thing to consider is that our custom element is just an HTML tag, and it resides inside your DOM tree, right? So it will look something like this. It can be inside your light DOM or your shadow DOM if you're already familiar with custom elements. And if we look at this image right now, this already kind of looks like HTML. It looks like a document. So we can take the provider and actually make a custom element our provider for our dependency. So now that we have an HTML tree, I think we can solve this problem with the power of events, basic native events. And they are great because they bubble up. This means that they will go up to the root of your document when you throw them. They are cancelable, so you can just stop the propagation at any point, prevent them from doing whatever default behavior they were expecting to do. And other two things that are very key to solve this problem is one is kind of seems like naive and silly, but when you're listening for an event, what you receive is an object. Therefore, you can mutate this object. So you can put whatever attribute or payload you want inside, like a dependency. And the other key factor that maybe we knew, but we didn't know that we knew, is that when you dispatch an event, the event is synchronous. This means that your code is the execution of your code is running. You dispatch an event, and the next line won't run until this event is handled or stopped or it reaches the root of your document. So events are synchronous. If we think about the synchronicity and the fact that we can mutate the event, what we can do is, after we dispatch it, in our event handler, we can create our, for example, date service. This is a singleton, kind of makes sense. Pass some configuration, and then insert that inside your event as a payload, as an extra property. Then let's stop the event so it doesn't go to the root of the document. And then our code execution will continue. So now in our custom element, right after we dispatch the event in our code, we can just pick up that property and set it as an internal dependency. So let's see how that code would look like, right? Let's start with the one that is going to create this dependency for us, the container or the provider. The first thing is that we need a list of providers because we might want to deliver more than one object, right? Then we just going to instantiate this. In this case, this date service is a factory receiving some properties and is using moment.js under the hood. Then what we want, of course, is listen for events. Let's call this event, because this is an expression event, right? It's not a click. Let's call it inject provider. It can have any name you want. And once that we are listening for events, when a children on our tree dispatches this event, what we're going to do is check, hey, are you requesting the dependency that I provide? Yes. Nice. Now I can set that dependency inside the event. Stop propagation because I don't want anyone else to override my dependency. And now let's go to the custom element. The custom element looks sort of like this. The first things that we are going to take advantage here, you can do this, by the way, with plain custom elements with the web component API, but I'm using lit for this. And with lit, you have this handy connected callback function that is going to be executed as soon as the element is attached to the DOM. So now that you're part of the DOM, you can actually dispatch events. Then let's create this inject provider event, and let's hack a little bit because you cannot pass any property to the new custom element. I'm passing that as a separate attribute. And I'm going to say, I'm going to dispatch an event, and the dependency I want is called date service. Now let's just dispatch the event up into a tree. It will bubble up, as we already stated. At some point, the provider we saw is on the tree. It will pick up this event. It will set the payload on the event. And then we can just take it. We already have our date service. So now I want to show you a little demo of this. It's nothing very complex. It's a little website. It's not going to be a live demo. I'm not that brave to show that. So these are two containers. One is orange, one is pink, and the children is just a white card that has no idea where it's located. So he throws an event and says, I want the color dependency. And since it's already loaded here, it says I'm in orange. With this move children button, what I do, I just take the, ID, the element by ID, and I do append to the other container, back and forward. So the element is never aware of its container, but this container is always communicating through this event dependency that was injected in the object. Let's go for another example, a little more complex. This is my very fancy product management tool. And I'm going to create a product that I want to release on Europe. It's going to cost 100 euros. And what I'm going to do, I'm going to decide to launch it on Europe. So when I throw this product here, I can get all sorts of details. I can get the actual price after taxing with my tax calculator service. I can get the proper time format because of the date service that we already were talking about. And also I can get some currency icons and some other stuff that I can do. So let's add the same product here so you can compare both. The product is never aware of who is being used, who is using. It's just aware of some date service, all the service that it requires to function. So lastly, I would like to go through the code of the example I just showed you. You can see it, and I will show it at the end of the slide as well. You can see the live demo and the source code. This is the Europe container. It's way simpler, and the reason is because we don't want to really add event listeners every time we need to provide a service or a factory or something. So I just extract that code and I put it in a mixing function. So it's hidden from us. But that code will work for any dependency that I want to provide, any type of provider at any level. So now that we don't have to think about how this is happening, we can think about what is actually the responsibility of this Europe component. So the Europe component has only one responsibility, and is to instantiate this service factory. So it sends the correct parameters. Internally, the factory is using Moment.js, and it's going to do their thing. So every time that someone is asking us for a date service, we're going to provide that instance in particular. And let's take a look on the product, which will be the children in this case. Same approach. Extract all the if patch event logic and everything outside, because we don't really care about that. We just care that the product requires a date service to function. And the way that we do that, we call this inject function that is actually hidden inside this mixing function, right? But we just call inject from date service, and now I have my date service instance. I can request time, I can request formatting, etc. So this proposal cannot be taken seriously if you don't compare what are the actual benefits. So let's take a look how will we solve this without this type of dependency resolution. Typically, you will have your component called product, and you will load a factory from some script or some library, third-party library, and you will pass down all the parameters that this factory requires to instantiate that. That's good, but also that's tightly coupled. So if you want to swap this factory for something else because it doesn't work, or the library you're using is too heavy, you want to make it a website lighter. Sorry, I forgot that I had this. Let's see our approach. In our approach, we still have some footprint, and the footprint is the mixing import and the extent. But now our code is totally decoupled, because the only thing that you or your colleagues can see when they're reading this component is that the date service has been requested to be injected in this property and nothing else. So some credits. This presentation is inspired on the dependency injection with custom element from Justin Fagnani. He made a nice podcast about it with Polymer a long time ago, and I took the core idea and I applied it to Lit, and I changed some things here and there. Also the blog post I mentioned and some art. And here's where you can see the resource for this presentation. So you can play at it and play with the idea. All right. Any questions? If you're online, you can always write, and I will get an email and I will reply you back. Yes. I'm the post message API. So you're talking about if you can provide dependencies with the post message API. So you have an application and an iframe, and you want your main application to provide a dependency into your iframe. I don't know if that will work because you can call me on this. I don't remember correctly if the post message API is only for strings. Sorry, you cannot pass objects, I think. If you cannot pass objects or functions, then I will think that the usability of that will be very restricted, right? Like you will have like just dependencies on constants or configuration files. That can be handy, of course, but if you cannot actually make some method pass down, it loses a lot of the value, right? Does that answer your question? All right. Yes. With TypeScript should work. So your question is, will this approach work with TypeScript? Yeah. Oh, how type safe? Well, if you have an interface definition, I will argue that it will be very safe because then you can pick up any implementation of this dependency, and as long as they share the same interface, that will work, right? Mm-hmm. Yes, you should probably do something like, in TypeScript in particular, do something like unknown type if you are very worried about it, because then you are certain you have 100% guarantee when you have unknown that every time you try to access a property or a method of your dependency, you need to do a check in runtime, right? That will be if you are very, very worried about it. But what I will expect is that this inject method will return something that, yeah, you need to implement the interface for. I haven't tested yet, but it will be interesting, definitely. Welcome. All right. So if there are no further questions, thank you everyone for your time and listening to me. Yeah.
Wow. Thank you so much, Matias. I was feeling some serious FOMO with some of the cool tech you're working on, I won't lie. But just like the gentleman in the second row during the refreshment break, he was working on his own side project. I'm going to also be working on mine too. Thanks for your inspiration.
Welcome.
Well, type safety has been mentioned quite a bit tonight, and it is really an interesting topic with so many forks. What we're going to talk about in the next one is quite a mouthful, and I'm going to try this one. Effortless full stack type safety with pure TypeScript by Jasper, who's a co-founder and developer at PressPlay. He's a full stack developer, but also loves making things as simple as possible around him. I asked him what was his greatest lesson he learned being a founder, and he told me, honesty goes a long way. Well, I'm honestly really looking forward to this talk tonight, so please come to the stage, Jasper.
Careful. Hello, everybody. I'm Jasper, and I'm here to talk a little bit about Pharaoh. But first off, I'm very curious. How many of you are working on backend in something like Express and communicating with it with Fetch on the front end? Or, yeah, not having built the backend also counts, but working with it. Okay, and GraphQL? Okay. Well, I'm here to tell you you're all wrong. But just kidding. Pharaoh is an alternative to that. Well, who the hell am I, right? That's my name, my Twitter. I've been building things since the 90s. So, your talk, thanks for the nostalgia. It was front page and frame sets for me. Really enjoyed that one. I'm also the co-founder of our little development agency here in Amsterdam called PressPlay and Pharaoh, which is why I'm here. A little bit of context about our company. This is just around the corner of our office. Fits nicely with the background, I guess. And this is on the inside. That's Camille over there. Is over here. Very talented, smart, and funny guy. I'm very proud to be on this adventure with you. So, well, basically, we like to build things, work hard, and have fun while doing it. We're mostly building consumer-facing software, websites, apps, full stack, and TypeScript all across the line. So some examples: this community for the web, and a mobile app for the Anything. It's called. It's a spin-off from Pathé Thuis. It's actually highly recommended to watch a movie because you can, with the app, you can book a private room to watch a movie with you and your friends. And when you're there, the app transforms into a remote control where you can control practically anything. And we also built a little app for the Slimste Mens, a pretty popular television show in here in the Netherlands. It has around 2 million users, and of which 50,000 active users a day, and they're pretty active. How we made that scale is a pretty interesting talk, but for a different day. Maybe also something for Camille more than me. The metrics what I am interested about are these kind of numbers. At the moment, we've got 100 separate API endpoints, and coincidentally, the same amount of types and interfaces. This grew over time, of course, but starting the project, we had a hunch that this could get quite complex, and it did. And of course, that's okay because that's the challenge of these kind of projects. But we also knew that when things get complex, the point where things start to break is the communication between the backend and the front end. And this would probably be a perfect time to mention that if I had a little bit more time between the second talk and now to prepare my talk, I would maybe adjust it a little bit, but I don't want to step on anyone's toes or anything. I just gonna continue with what I prepared. Let's see. Well, let's take a look how we would build this with something like Express and Fetch. To start off, we want our data model declared in TypeScript on our backend. This is a very simplified version of it, of course. We've got a game, and the game has a game type and an ID. And to get that game, we've got this Express API endpoint, which returns the document of the game based on its ID. Well, fetching this on the client, in the context of the client, we would like to have type checking as well, of course. Well, the most naive way to do this is to duplicate the domain model. And from this point, we can use the fetch API to reference the backend based on a URL, get that response and transform it to JSON. And whatever that JSON is, we'll cast it to the type we're expecting it to be. Okay, that works, but what if something changes on the server? For instance, the game type C doesn't exist anymore, it's now D, which is a cryptic name, but let's leave that aside. From the context of the client, nothing's wrong. We won't get any compile errors because we still have the local version of the domain model. And note here, when building a mobile app, you can't guarantee that every client in the wild is up to date with the latest version. So you can't deploy the server and deploy all the clients at the same time. You have to account for backwards compatibility. So, from the context of the client, everything seems fine, but runtime, this will probably crash way down the line when you're actually rendering a game. So, the obvious next step will be, well, why won't you just share your models across separate projects? Well, that is possible, but believe me, it's quite a hassle. But for this demo, let's assume that we figured it out. We've moved our data model into a third project, and it's the same model. And both the API and the app are using this third project. Well, that's great, because in this situation, the app will be up to date with the data model. So you will get you will get compile errors, which will force you to fix the error somewhere down your code base. But what if the API is emitting data that doesn't belong there? For example, we never had a game type E, but your database could be corrupt. Or in this case, we totally forgot to type out the response. Or the new version of the app expects a game type E, but the old version of your app doesn't know that's there. Well, let's make a little bit room over here, because we'll need it. Okay, so to fix this kind of issue, you actually need to validate the incoming data on the client. That means that if you validate it, you can throw an error very early on, so you can know that it's not a bug in your app, because why it's crashing, but it's corrupt data coming from the API. So in this case, it would be something like this. We're validating that the incoming type of the game is one of the game type cases that we're expecting it to be. Must say it's a bit clunky, especially because this is just one of the properties of the object. But it works, and it's better than blaming the app while the API was incorrect, right? So this is the solution that we've got over right now. So seems about right, right? Well, nope. Someone saw it. Well, we made a typo in the API URL. So easy to fix, but also easy to create bug. Yeah, I'm not sure about you, but I don't like this experience at all. We thought we were gonna build a great new feature, but we're mostly fixing bugs or preventing ourselves from making one in the future. And it's mostly about silly mistakes, right? API URLs, data model that doesn't match up. It's silly in a way. Also, sharing models between projects, it is possible, but a hassle. And in practice, it's still not enough. So, in our opinion, express and fetch, even when you've got TypeScript, for us, we thought it's not enough. GraphQL solves a lot of the same problems, especially when you combine it with CodeGen to generate TypeScript from your GraphQL schema. But also, it introduces a lot of complexity, and frankly, it's just not our style. If I got time, I also have a small comparison for GraphQL. So you're thinking there should be a better way to do this, right? There is, and it's called RPC. It's not a new concept at all, but it is really cool. It stands for Remote Procedural Call, and it means that you define a function and you can call it on from an entirely different environment. In our case, defining a function on the backend and calling it from the front end, as if it was a local function. So we took that concept and we applied it to front end and back end development in TypeScript. And that's basically what Pharo is. So let's take a look at the same example, but in Pharo. Step 1 will be adding the same domain model back into the API, because that's what you said, the server should be the single source of truth. I agree. Next step will be defining your API call, your API endpoint. And in Pharo, you can do that in regular TypeScript. So you start to think, how would I use regular plain TypeScript to define a function that does something? Well, in this case, it's an async function called getGame. It gets an ID and it returns a promise of a game. Nothing more than that. The next thing to do is wrap that function inside of what we call a service. And there could be any number of functions grouped inside of each service. And start up the server. This will do a couple of things. First, it will analyze your backend code. Based on that, it will run a server, an HTTP server, to handle incoming requests. And also, it will generate a type-safe client for your front end. So, while developing, you can chuck that to the background. And when you change the backend, it will refresh automatically, of course. So, now we've got the Pharo client. And with that, we can get the game by using autocomplete. Because what it generates is plainly regular local TypeScript. So your IDE should work just fine. And from the Pharo client, you can get to the service. And from that service, you can get to the game. And this is all type safe. So this will get a compile error because I forgot to add the ID. And if you take a look at the type of the game, it's a promise of a game, like the function on the backend defined. So that means we can await on it and get the actual game, like you could do with any local function. And as a bonus, Pharo also exposes all your domain models as well, so you can do logic like this. But I think that's pretty great, but still, you could get into a situation where your API exposes data that's incorrect. In this case, we used an any, which you shouldn't do, of course, but let's say you will. Or your database is corrupted somehow, or again, your app is behind on your API and thus behind on the data model. Well, Pharo automatically validates all incoming and outgoing data based on the TypeScript that you've defined on the backend. That means in parameters and return types, everything is validated. And this will automatically throw an early error as soon as you fire this function. So this is our solution right now. And now on to the comparison. If I take a look at it, first it's a lot shorter, but more importantly, it's way more to the point. If you take a look at the Express example, we see app.get, rest.send, response.json, all that kind of stuff, the validating. It's kind of clutter getting in the way of what we're actually trying to do, which is just getting the game. Also, from the perspective of the backend, it gives me way more confidence that I can refactor our API either which functions or what they called or arguments, because I know compile time if our clients will still work without even running them. And from the perspective of the client, I can be assured that I'm communicating with the backend correctly without making stupid mistakes. And I can assume that the incoming data is correct without doing anything. And also sharing the data models is for free. So basically, Pharo is all about defining a function in regular TypeScript on the backend and calling it on the front end, like it's a local function. So what about error handling, right? Because if it's a local function, I should be able to throw an error in that function and catch it afterwards. Well, you can, but first, let's get this to a little bit more realistic example. We're referencing some kind of database to get the ID, to get the game. And let's wrap this inside of a try catch, like you would do with any asynchronous function. For this example, let's say a game isn't really deleted, but we've got a soft delete based on a deleted at property. We'll introduce a custom error, like you would do in regular TypeScript, and throw it when the deleted at property is set on this game. Well, the great thing is Pharo exposes this custom error, so you can catch it on the front end. So, on top of that, when building such a custom local error, you could add extra properties. So, of course, we built that as well. So in this case, we can declare this is not just deleted, but this was deleted at a certain moment. And you get that property on the client as well. And note that type is a date. Pharo automatically parses that date object to an ISO string and back to a proper date object when transferring dates between backend and frontend, both ways, in errors, but also in arguments and return types. So that means you can do something like this. You can use the regular date API. Yeah, so in short, Pharo is based on pure TypeScript, and writing pure TypeScript on the backend with the least amount of API level as possible, and doing cool stuff with it, like end-to-end type safety. And this brings you in the situation where your backend and frontend are still separate worlds, so you can pick the best tool for the job in both areas, but they act like they're not separated at all. On the front end, by the way, it means you can use any front end stack you want. It works with React, React Native, should work with Svelte, as long as there's TypeScript. A little side note about how we run this, because we're actually doing two things at the moment. We're running the Press Play agency, and meanwhile we're building Pharo. Well, that actually works pretty nicely because we can build better projects for our clients because we've got Pharo, and we can build a better Pharo because we're working on it ourselves. The Slim's Demands example was our first project that we built with it, and that was more than 2 years ago, and we didn't touch Express ever since. So we thought it's time to make it public, which we did last month, mainly to figure out we really love it. We really love to use it, and we want to know if we're the only one. And if there are more people that are enthusiastic about it, we would love to build a sustainable business around it without the other lines making it stop. The open source tool will always be free, of course. So if anyone has some great ideas about the upper part, that's something we're developing at the moment. Would love to talk to you. And that's it. Any questions? Yeah. Well, under the hood, it's regular HTTP. So you can still inspect all the traffic, if that's what you mean. Yeah, yeah. Well, it is a post. Yeah. Oh, you're you're up to. Oh, nice. It's post all the time, but in practice, like with error codes, for example, in practice you don't really need it anymore because you handle it like it's a local function. Yeah. You're just calling a server, a service, which has a function, and under the hood it's a URL with a regular post body. But really, you're not really working with that kind of stuff. You're treating it as a local function. Yeah. Well, that's something for Camille. That's really intensive work with the TypeScript compiler. If I, oh, sorry.
So to talk about bit about the technical stuff under the hood, we use the TypeScript compiler API to analyze your models like interfaces, types, enums, all that kind of stuff. And then based on that, we generate code for you which actually parses your incoming and outgoing data. And one advantage of using the TypeScript compiler API and just TypeScript instead of GraphQL, you can just use all features TypeScript has to offer, like generics and that kind of stuff.
Yeah. Yeah, generating the validators happens build time, but running them and validating the actual validating that happens runtime. Well, we're analyzing your backend code, your data model, and for each type, we generate validators, which we run in runtime. Yeah. Nice question. Well, it's pretty similar, but TRPC is based on tools like ZOD, where you define your data model in an imperative way instead of regular TypeScript. So I think there are a couple of differences and similarities, but that's the biggest difference. Yeah. At the moment we don't. No. But I must say, in 2 years using it, we didn't need it. Yeah. Yeah, you do. Well, actually, the name of the service and the RPC itself are in the URL, and the payload you're giving it is in the payload. Yeah. Yeah. Exactly. Yeah. 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 Great question. That's a feature we're intend to work on heavily because that will make it far easier to build native apps or React Native apps because you can define the moment you're publishing a new version of your API, and apply a version to that. And when we detect breaking changes in your data model, we can limit that basically and give you the tools you need to make migrations and stuff. Does that answer you? No, no, it's just one version. But the server generates a manifest, which is an extracted way of an extracted model of your data model, which we use to generate the client. And basically, when you keep that in mind when reviewing PR on GitHub, for example, you can pretty well spot breaking changes. Yeah, but it's a very important feature that we intend to work on. Totally, yeah. Yeah. Also, one of the features that we've got in mind, because we know your data model and your functions and which parameters and return types it has. So we could, I say now quite easily, but probably not easily, we could generate documentation for that. Yeah. 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 Yeah, well, we do that on both places because when you're getting invalid data from your client, from the perspective of the server, that means something is really wrong, and maybe a very old version of the app or something. So we do it on both places. Yeah. Yeah. Both. Yeah. Yeah. I'm not sure I understand your question. Yeah. Yeah. Oh, yeah. Yeah. We did a lot of things last 2 years. Now, yeah, now I remember. Okay. You too? Sorry? I can't understand you, mate. Yeah, yeah, we intend to work on that, but we don't have at the moment. But knowing your data model and your functions, it can be done very well, but didn't come to it. Okay, well, thanks a lot for your time, and thanks a lot for being here.
Thank you, Jasper. Wow, very brave answering those questions. Very well done.
The other part was
It's great to
scarier.
see trial and tested such verbose solutions from devs working hard. Really, really inspirational. That, ladies and gentlemen, brings us to the end of our evening, but it does not end here. We still have refreshments being served outside. Please feel free to chit chat and network with fellow colleagues of the industry. Once again, thank you all for being present today. We really appreciate you being here in person. Also to everyone on the live stream, thank you again. And to all the legends up there, making sure everything runs smoothly, thank you again. And to our sponsors for this amazing venue, we could not have done it without you. Have a great evening. It's been an honor being your MC. And I will see you at the next one on the 17th of November at Uber. Have a lovely evening. Dankjewel. Goedenavond.
Sometimes I forget there might be more. Maybe